is just before midnight on August 15, 1977. At a radio telescope in Delaware, Ohio, a machine is doing what it has been doing every night for 4 years, scanning the sky, listening, recording. No human being is present. The telescope runs automatically, printing its data onto long sheets of paper that will be reviewed later. Tonight, like most nights, it finds nothing unusual, except that tonight, it does. At 10:16 p.m., something reaches the telescope from deep space, a narrowband radio signal, arriving at a frequency of 1,420 megahertz. It lasts exactly 72 seconds. Then it stops. The machine records it faithfully on its printout, encoding its intensity as a sequence of numbers and letters. Then it moves on, scanning the next patch of sky, indifferent to what it has just captured. 3 days later, a volunteer astronomer named Jerry Amon sits down to review the printout. He works through the data methodically, column by column, the way he has done hundreds of times before. Then he stops. He stares at the sequence of characters in front of him. He picks up his red pen. He draws a circle around the data. And in the margin, he writes a single word. Wow. That word, scrawled in red ink on a sheet of computer paper in a small Ohio observatory in 1977, became the name of one of the most debated and tantalizing mysteries in the history of science. Nearly 50 years later, the WOW signal has still never been fully explained. It has never been heard again, and it remains the single most compelling candidate for a signal of extraterrestrial origin ever detected. This is its story. To understand why the WOW signal matters, you first need to understand what scientists were looking for and why. In the 1960s and 1970s, a group of astronomers had a bold idea. If there were intelligent civilizations elsewhere in the universe, and if they were trying to communicate, they would likely use radio waves. Radio waves travel at the speed of light, penetrate interstellar space efficiently, and require relatively modest technology to produce and detect. They were, in the view of these scientists, the most logical choice for a cosmic communication system. But which frequency would an intelligent civilization choose to transmit on? The answer the scientists settled on was elegant. Hydrogen is the most abundant element in the universe. Every civilization with basic knowledge of physics would know that hydrogen emits radio waves at a frequency of 1,420 megahertz. This frequency became known as the hydrogen line, or the water hole, a quiet region of the radio spectrum that scientists believed any intelligent species would recognize as a natural meeting point. If anyone out there was trying to be found, they argued, they would be broadcasting near 1,420 megahertz. In 1973, Ohio State University converted its Big Ear radio telescope to search for exactly this kind of signal. The project ran for 22 years, making it the longest-running SETI program in history. Night after night, year after year, the telescope scanned the sky and found nothing unusual, until August 15, 1977. The Big Ear telescope was not a traditional dish. It was a fixed, flat reflector, essentially a massive flat surface that collected radio waves from a strip of sky as Earth rotated. It could not be steered or pointed at specific targets. It simply listened to whatever passed overhead. On the night of August 15th, the telescope was scanning a region of sky in the direction of the constellation Sagittarius, and at 10:16 p.m., it detected something. The signal arrived at 1,420 megahertz, the hydrogen line. Exactly the frequency scientists had predicted an extraterrestrial transmission might use. Its intensity was extraordinary. The standard measure of signal strength in radio astronomy is a ratio comparing the signal to background noise. Most signals detected in routine scanning register between 1 and 2 on this scale. The WOW signal registered at 30 times more powerful than the background noise of the universe. It also showed a characteristic pattern. It started weak, grew stronger, reached its peak, then faded again over the course of 72 seconds. This rise and fall is precisely what you would expect from a signal with a fixed point source in space, passing across a stationary telescope beam as the Earth rotates. It is the signature of something celestial, not something local. It was narrowband, meaning it occupied an extremely precise slice of the radio spectrum, rather than being spread across multiple frequencies. Natural radio sources in space tend to be broadband, emitting across a wide range of frequencies. A narrowband signal concentrated at a single precise frequency is strongly associated with artificial transmission. It ticked every box that the SETI scientists had defined as the profile of a signal worth taking seriously, every single one. And then it was gone. When Jerry Amon circled that data and wrote "wow" in the margin 3 days later, he was not claiming he had found aliens. He was a careful scientist. What he was expressing was astonishment that something had appeared in the data that matched so precisely everything they had been hoping to find. He later said that when he first saw it, he asked himself what response could be more appropriate than "wow." In the months and years that followed, astronomers attempted to detect the signal again. Big Ear itself scanned the same patch of sky dozens of times. The Arecibo Observatory in Puerto Rico, one of the most powerful radio telescopes ever built, looked for it. Other observatories around the world listened. Nothing. Not once. In nearly 50 years of searching, the signal has never been detected again. This is perhaps the most baffling aspect of the WOW signal. A signal that's strong, arriving at that frequency, should theoretically be detectable again. If it was a beacon of some kind, designed to be found, why did it only transmit once? Or more precisely, why have we never heard it again? There are several possible explanations, and scientists have debated them for decades. The first and most straightforward possibility is that the signal was terrestrial interference of some kind, a piece of human-made radio equipment producing a signal that the telescope happened to pick up. This is the most common explanation for anomalous readings in radio astronomy, but the WOW signal resists this explanation stubbornly. Terrestrial interference typically appears in multiple channels simultaneously. The WOW signal appeared in only one of the telescope's 50 channels. Terrestrial signals also tend to remain present when the telescope revisits the same area of sky. The WOW signal was never found again despite extensive searching. And perhaps most damning for the terrestrial interference theory, the rise and fall pattern of the signal matches a celestial source, not a local one. The second possibility is that it was a natural astrophysical phenomenon. Some natural process in space producing a narrowband radio signal at the hydrogen frequency, powerful enough to register at 30 times background noise. The problem is that no known natural phenomenon fits this profile cleanly. Natural radio sources in space are almost universally broadband. A narrowband signal of this intensity at this specific frequency has no satisfying natural explanation in the existing catalog of known cosmic phenomena. The third possibility is the one that scientists are most reluctant to state directly, but that the data refuses to entirely exclude. It was artificial, not made by humans, made by something else. In 2016, an astronomer named Antonio Paris proposed a new explanation. He suggested that the signal had come from a comet, specifically two comets called 266P Christensen and P85 Borisov, which he said were passing through the region of sky where the signal originated in 1977 and could have emitted radio waves at the hydrogen frequency from their hydrogen clouds. The theory attracted significant attention. It offered a natural explanation that did not require either terrestrial interference or extraterrestrial intelligence, but it was met with substantial skepticism from the scientific community. Other researchers pointed out that comets were not known to emit radio signals at 1,420 megahertz, with anything close to the intensity of the WOW signal. They also questioned whether the comets in question were actually in the right position in 1977. The comet explanation remains contested and has not been accepted as a consensus answer. Then, in 2024 and 2025, new research emerged that changed the picture again. A team of astronomers led by Abel Mendez at the University of Puerto Rico conducted a new analysis of the original data from the Big Ear telescope, incorporating decades of previously unpublished observational records. Their study, part of a project called Arecibo WOW, used modern signal analysis techniques to re-examine the signal with fresh tools unavailable in 1977. Their findings were significant. The new analysis confirmed that the signal was almost certainly not caused by terrestrial radio interference. It also provided a more precise location for the signal's origin in the sky, and it revised the estimated peak intensity of the signal upward to approximately 250 Janskis, 4 times stronger than previously calculated. As for what caused it, the researchers proposed a new hypothesis. They suggested that the WOW signal may have been caused by a sudden brightening of the hydrogen line in interstellar clouds, triggered by a powerful transient radiation source such as a magnetar. A magnetar is a neutron star with an extraordinarily powerful magnetic field, capable of releasing enormous bursts of energy in what are called soft gamma repeater events. The researchers proposed that such a burst could have energized clouds of hydrogen in interstellar space, causing them to briefly emit an intense radio signal at exactly the hydrogen line frequency. It is a compelling hypothesis, but Mendez himself was careful to note that the case is not closed. This study doesn't close the case, he said, it reopens it, but now with a much sharper map in hand. What is particularly striking about the new research is what it confirmed as well as what it proposed. The 2025 analysis found that the signal was not of terrestrial origin. It found no satisfying conventional astrophysical explanation that fits all the parameters, and it identified more precisely where in the sky the signal came from, narrowing the search area for future observations. In other words, nearly 50 years after Jerry Amon wrote WOW in a margin, scientists are still actively working to explain what he found. And the most recent research, conducted with the best tools available in 2025, has not produced a definitive answer. There is a broader question that the WOW signal forces us to confront, one that scientists approach carefully, but that the public has always found irresistible. What are the odds that we are alone? The universe contains an estimated 2 trillion galaxies. Our own Milky Way galaxy contains somewhere between 100 and 400 billion stars. Studies by NASA and other organizations estimate that most of those stars have planets. A significant fraction of those planets are in what astronomers call the habitable zone, the range of distances from a star where liquid water could exist on a planetary surface. The numbers are almost beyond comprehension, even if the probability of life emerging on any given habitable planet is vanishingly small. The sheer number of opportunities across the universe makes the existence of other life somewhere seem statistically plausible to many scientists. And yet we have detected nothing. No confirmed signal, no verified transmission, no contact of any kind. This paradox, the apparent contradiction between the high probability of extraterrestrial life and the complete absence of any evidence for it, was articulated by physicist Enrico Fermi in 1950 and is known as the Fermi paradox. If intelligent civilizations are common, where is everybody? The WOW signal is the closest thing we have ever found to an answer, or at least to a hint of one. It appeared once at precisely the frequency scientists predicted an extraterrestrial civilization would use to make contact. It was 30 times more powerful than background noise. It had the characteristics of a signal from a fixed point in deep space, and it has never been explained to the satisfaction of the scientific community despite nearly 50 years of effort. Jerry Amon himself, the man who first identified the signal and whose red pen gave it its name, remained cautious throughout his life. He did not believe the evidence was strong enough to claim contact with an extraterrestrial civilization. But he also never dismissed the possibility. He simply said the data was what it was, and that the signal deserved to be taken seriously. He was right on both counts. What is perhaps most haunting about the WOW signal is not its intensity or its frequency or its perfect fit with the SETI profile. It is its duration. 72 seconds. Whatever it was, it lasted 72 seconds. Big Ear was listening. It was recorded. And in a universe 13.8 billion years old, in a galaxy containing hundreds of billions of stars, in a search program that ran for 22 years, a single moment of 72 seconds was what we caught. If it was something natural, we have never replicated it or explained it convincingly. If it was something else, we have never heard it again. In August 1977, something reached across space and touched a radio telescope in Ohio for slightly more than a minute. On a printout in a small observatory, a man picked up a red pen and wrote one word. We are still trying to figure out what to write back. That is the WOW signal. If you want to go deeper on the mysteries and unknown events that science still struggles to explain, subscribe to Horizon Archives. We'll see you next time.